Up until now, we've factored quadratics. Now we're going to use that factoring to solve the quadratic, which means actually find out what the variable x is equal to, what number it's equal to. So here's how this is going to work. Laid my chalk down somewhere. Okay, up until now, we know that we need to factor, and in order to solve for x, we're still going to have to factor our trinomials. So we have already checked for greatest common factor. That's our first step. We need to check for greatest common factor, but we found out if this is the invisible one and there's not a variable there, there's probably not a greatest common factor. This is not a special because it has 3 terms, not 2. Specials, we found out yesterday, have only 2 terms. Then our third step, if you're looking at your factoring steps, was to look and see if we have any groupings. Now groupings was 4 or 6 terms. We have 1, 2, 3 terms, not 4. So we don't have a grouping. So our fourth step in our factoring steps was to factor into 2 parentheses, and that's where we are. So the front times the front gives us the front. We save the middle term till later. The back number times the back number has to give us 12. So 12 is 1 times 12, 2 times 6, and 3 times 4. So we have to look at each one of these pairs. This is just a review. Look at each one of these pairs and decide which pair will add or subtract to give me 8. And
2 and 6.
that if I add these together, I'll get 8. And so those are the numbers we use in the back of our parentheses. Remember, if the front variable, if they are exactly the same, then it doesn't matter where the 2 and the 6 go. Now we're going to check and see if this truly works and look for the sign that we need to have here and here to make sure that's a negative. So these multiplied together are 2x. And 6x. Now we need to put this together, add or subtract, to get a negative 8. And if I'm going to get a negative 8, I need to add these together. But if I add them together the way they are, I'll get a positive 8. So I need both of them to be negative, to add negatives and get a negative 8. And so here is my factoring. It's a quick review of factoring. If you need more instruction, go back to one of the YouTube videos and there's a more in-depth discussion on how to factor. Now, we're to the place where we have always come for factoring. Now we're going to solve quadratics. So the next step for us is, if I'm going to solve a quadratic, the number one thing you have to make sure is it must be equal to 0 before you can solve anything. So this quadratic, in order to solve it, it has to be equal to 0. So what you're going to start to see is this. They just put an equal 0 on it, which means when I factored this part, it's equal to 0. Okay, easy enough. And you'll start to see that on page 3 of our packet 3. Okay, a quadratic, again, I need to tell you, a quadratic must be equal to 0 before it can be solved. You will come across problems later, I don't think today, but you'll come across problems later that you have to make your quadratic be equal to 0 before you can start. The problems you're going to work together today, especially page 3, they're all going to be equal to 0 already for you. So now, what I want you to do, this is how I teach it to everyone. I want you to just stop for a minute, and I want you to imagine you're sitting in a third grade class. A third grade class, and your teacher comes in all smiles, and she says, I have a riddle for you. I want you to try to solve this riddle. And she said, in this hand, I have a mystery number. And in this hand, I have a mystery number. Now, I need you to tell me about these mystery numbers, and I'll give you a hint. If I multiply these together, if I multiply this number times this number, I will get an answer of 0. Okay? Now, what can you tell me about these numbers?
One of them has to be 0.
Yes, one of them has to be 0. That's the only way we're going to get the answer of 0, correct?
Yep.
Yes.
Let me ask you this. Could both of them be 0?
Technically, yeah.
Yes, because 0 times 0 will also give you 0, correct?
Yeah.
Yes.
So what we decided here is one of them could be 0, the other one could be 0, or both of them could be 0. Yes?
Yeah.
Okay, keep that concept in mind when we look at what we just finished. Let's pretend that this is one of the mystery numbers, and this is one of the mystery numbers. Now, we said if these mystery numbers are multiplied together, they will get 0. So what you just told me is one of them has to be 0 and both of them could be 0. So the way we solve this quadratic is we say, okay, both of them are 0. And so we have x minus 2 could be 0, and or x minus 6 could be 0. And then all we have to notice that I just did this and this, because this mystery number could be 0 or this mystery number could be 0. So now I'm going to do a very elementary solving for x. We want the x by itself. So we plus 2, this should be very familiar to you. And so I'm left with x equals 2. This is one of our answers. And then I come over here, I want the x by itself, so I add 6. And I have x equals 6. Now for a quadratic, the majority of the time, not always, but the majority of the time, you're going to have 2 answers indicated here. Not always, you might just have 1 answer, you might have 0 answers, but the majority of the time, probably 75, 80% of the time, you're going to have 2 answers to this problem. And this is how you solve. Do you see how short a trip it is from factoring to finding out what x is actually equal to? Not bad?
No. No,
Let's
pretty good.
Pretty good. We're going to do several others. We have Shaniqua coming in. Let's do another one.
Uh-oh.
I'm going to go ahead and write this. Must. Good morning, Shaniqua.
Good morning.
So before we solve a quadratic, we must make it equal to 0. It must be equal to 0 before we can solve it. So let's look at another one, and then I'll work a couple or 1 or 2 off of your homework. Let's do this one. doesn't come out. Okay. That's not a good one to choose. I want, here we go.
Uh-oh.
Okay, so what we're going to do now today is not only factor this, but they want me to continue on after I factor and actually find out what W is equal to. Now, this one's a little more involved because it has a leading coefficient that is not 1. So we talk about the trial and error factoring. So here's what we're going to do, and I don't know the answer to it, so we'll see. Okay, we need to check for greatest common factor, and you're looking at the 2, but 2 won't go into here. So we don't have a greatest common factor, we don't have a special, we don't have a grouping, so here we are. And we're simply factoring. Shaniqua, we decided that I don't want to do packet 1 or packet 2 today. We moved straight to quadratics packet 3. You should have received an email on that before spring break. So we are in packet number 3. I didn't like the order that I put it in originally. So we're in packet 3. Okay, so the front times the front has to give me this front term. So I know it's going to be W and W because I need a W squared, but I also have to take care of this 2. And the only factors for 2 is 1 times 2. So I guess I don't have a choice. I'm going to have 1 and 2, correct? Then we're going to just save it for later, and we go to 27. Now, all the factors of 27 are here. 3 times 9, 4, 5, 6, 7, 8. This is it. Now, this is a little more difficult because you can't look at this and just see what makes 21 because the front numbers are different. So what we're going to do is just try some. Let's do, we're going to use 3 and 9. I like that one better to start out with. So I'm just going to try this. So this makes 6W. This makes 9W. And there's no way I'm going to get a positive 1W out of that. But we call this a trial and error, which means I can switch these. So this is 9 and this is 3. I just switched the back numbers because these are different. So the positions matter. So now I have 18W and 3W. And sure enough, if I add these together, I will get a positive 21W. So this is correct. This is the correct factoring. Again, if you need some help, more help on factoring, there's several YouTube videos to handle that. So this is our factoring, but remember this time, they not only want us to factor, which you have to do to solve, they want us to actually solve it, which means I need to find out what W really is. We found out before we can solve a quadratic, it must be equal to 0. So now today, you're going to see problems with equal to 0 because it has to be before you can solve it. And so like in our last example, here's a mystery number that could be 0, or this mystery number could be 0, or we found out both of them can be 0. So let's just set them that way. I'm going to take this one and say W plus 9 could equal 0, and or 2w plus 3 could equal 0. When we solve these separately, we're going to find out what w is actually equal to. If I want the w by itself, I subtract the 9. Now I have w equals -9. Here's one of my answers. I want the w by itself. I'm going to have to subtract 3. Now I have 2 w's equals -3. But I just want the w. Since it's multiplied to 2, I've got to divide by 2 to get rid of it. If I do it on this side, it has to be done on this side. And so now w is equal to a -3/2. Did my screen go that low?
No.
Almost. Okay. Now, just as a side note, you don't have to worry so much about this right now, but when you're solving quadratics, to me, it helps a lot if you know what you're actually finding. When you find this, most of the time we call this x, right? Most of the time these are x's. What we are finding is where the graph of this quadratic actually crosses the x-axis. So watch this. Let me go over here in this little gap. Later on, we're going to graph a quadratic. This is the x-axis and the y-axis. And a quadratic either looks like this, it's a parabola, or like this. Whenever I graph any quadratic, it will come out similar to one of these. Now, our answers, x equals -9, 1, 2, 3, 4, 5, 6, 7, 8, 9, and -3/2 is kind of in here. This is the answers that you're finding. You're finding where this parabola crosses the x-axis. Do y'all see? You don't have to graph right now, but some learners need to know, what in the heck are we even doing this for? Well, a quadratic quadratic means the largest exponent is 2, okay? And any quadratic will create a parabola like this or this. That's what the graph will look like. And when we solve a quadratic, these answers are the x-intercepts. If they're always on the x-axis, even if this is a w and this is w, it's still where the parabola crosses the x-axis. Do you guys understand? Does it help any?
Yeah.
To know what you're actually doing? Maybe? Is it too much? Am I going too fast?
I'm good.
Are we good? I can still do another example. Shaniqua, you had that face.
I can take another example.
Okay, you could take another one. I think I want to do at least 2 more examples because, yes, I want to do 2 more examples for sure. And then I'll do whatever y'all need. Let's try this one because this one will look strange to you, although we've done some of them. Okay, here, although it's not really long, this is a quadratic because the largest exponent is 2. So this equation right here will give you one of those parabolas like I showed you. So we're going to begin to work on this. And our first step, you guys remember the steps. The first step is to look for a GCF. So when I look here, this is an invisible one. So there isn't a GCF for the numbers, but look, this is like 1 times k times k, and this is 7 times 1 times k. We ignore the ones. And now we're trying to find something that matches. That is the greatest common factor. And sure enough, I have a k that matches a k. No more matches anywhere. So k is our greatest common factor. Then we're going to tell whoever what is left after I divide a k out of all the pieces, all the terms, okay? So when I divided a k out of this term, I'm left with another k. I use the plus, and when I divide the k out of this one, I'm left with a 7. Correct? Now
Yeah.
this is all the factoring that has to be done in this one. So if my factoring is finished, remember I cannot solve unless these are equal to 0, and for now, all of them will be equal to 0. We'll hit the higher step when we get there. So now, remember how we had one mystery number and another mystery number? Remember?
Yeah.
Yeah.
We actually have 2 mystery numbers because they're multiplied together. This is a mystery number by itself, and this set is a mystery number, okay? If I multiply these together, I have to get 0, so I know that either this is 0 or this is 0, or they can both be 0. So this is where the factoring is done. Now I'm going to solve. I'm going to make k equals 0 and or k plus 7 will equal 0. This one is already solved. K is already by itself. So one of our answers is actually 0. And this one I want to solve for k. And so k can also be a -7. Y'all see? So it's a
Yep.
little bit different, but I still have 1, 2 mystery numbers. So I have to set them both to 0. Just again, to explain to you, one of our answers is 0 on the x-axis. And one of our answers is -7. And our parabola will intersect the y or the x-axis right there. This is what our graph will look like. Now these intersection points we'll find out later, they're not only x-intercepts, they're answers, solutions. They call these roots, okay? These are x-intercepts. These are different words they're going to use for these. X-intercepts, roots, this is a common one, roots, or zeros. Okay? These dots, these solutions can be called x-intercepts, roots, or zeros. So what you're finding, but right now, you just need to be able to factor, then solve. Okay, that's what we're going to do today. I want to do one more of these, and then we'll go to your actual worksheet and see if there's anything that might confuse you. Any questions on this one?
No, I'm good so
No.
Everybody's good so far? Okay.
Yes, ma'am.
Here's another one that you might find, and it calls into play our specials from yesterday. So let me find it right here. Okay, since we know we're going to be solving, I'll go ahead and put my equals 0 out here. Okay, so for this part, I need to look for greatest common factor first. If there's an invisible one and no variable, probably not a greatest common factor. Then my second step is to look for specials. And if you weren't online yesterday, you need to go back to yesterday's YouTube to find out about specials. Okay, and you should all have a paper that explains what the specials are and how to factor those. This one is the difference of two squares. That means I can find the square root of this, and I can find the square root of this. Okay, so the square root of d squared is d. Be sure to circle the square root up here because these are the numbers that you'll use in your factoring. The square root of 36 is 6. So these are the numbers that will be in the parentheses. And we found out yesterday to factor the difference of two squares is you put these numbers in the first parentheses and you put them in the second parentheses, and the only difference is the signs. So this is the difference of two squares. This is one of the specials. It's very important for you to look at yesterday's YouTube, and then you'll know what I'm talking about here. So this is factored and it's equal to 0. Mystery number times each other gives us 0. So this has to be 0. Or this has to be 0. Solve them separately. And so these are our two solutions, or our roots of where the parabola crosses the x-axis. D equals a positive 6, D equals a negative 6. Can you see why our factoring was so important? Yes?
Yeah.
Because you can't solve unless you can factor. Any questions on this one?
No, I think I'm good so far.
Okay, so we're actually going to go now to the first 2 pages. Some of you that came on late, the first 2 pages in packet 3 are simply review and practice on factoring, nothing new. Okay, then the 3rd page, some of you might need to mute. There's a lot of background noise. Somebody with a cold. Okay, so, okay, this is the page now. This is page 3 if you number your pages. And remember, we are not in packet 1 of the quadratics, we're in packet 3. I didn't like the order that I had them in. So I'm going to work number 1. Now you should recognize from this that they did part of your work for you. There was a quadratic up here somewhere and they went ahead and factored it for you. All they want you to do is practice solving from this step. So this is our mystery number times a mystery number gives us 0. So I know that one of these has to be 0. Notice when I write them down, I don't have to use the parentheses anymore. This one is here, this one is here. If I multiply them together, they have to give me 0. So this has to be 0 or that has to be 0. So I want the x. Again, you can see why I pushed you to find out how to solve equations, because we're doing it forever. This is multiply, I have to divide. So now x equals 1/2. You don't have to worry about, what does this mean? It's the fraction, okay? If it's a fraction that needs to be simplified, be sure and do that. So one of the places of intersection is 1/2. And then we solve the other one. Careful of your negatives now. Be sure to follow the negatives through. And so this is the other one. Any questions? This whole page, they have already done the factoring for you, and they have also made everything equal to 0, so there's not a problem there either. Okay? So they've done the factoring for you on this page, made it equal to 0. Let's see what they have in store for you on the next page. Okay. Next page. Page 4 begins like this. And up at the top, it says ES1, quadratic equation factoring. Now this one, they're going to want you to factor and solve. It says solve, and you can't solve until you factor. Okay. So I'm going to move down to one of these. We can do whatever you want us to, but I'm going to move down to some of these that aren't equal to 0. I think I'm going to go ahead and do both of these, 6 and 7, because they're actually already factored for you. But we have to undo some stuff because they're not equal to 0. See here? And we can't do anything until this thing is equal to 0. Same thing over here on 6. It's not equal to 0, so something else has to be done. So let's start with number 6.
Okay.
Number 6. Now the problem here is that it is not equal to 0, so you can't do squat until it's equal to 0. Now the easiest way to do that is to subtract the 99, but what are you going to subtract it from? You can't go up into here and subtract it from 2. So if we remember our order of operations, please excuse my dear Aunt Sally, we need to take care of the parentheses first. So I am going to use my distributive property and make this r squared plus 2r equals 99. Okay? So we're getting closer because now I'm done with my parentheses and I still want this to be equal to 0. The only way I can get this side to equal 0 is to subtract this thing off of here. Whatever I do to one side, I need to do to the other side, which I will, but be careful. This is a constant, which means it's a plain number. I can't subtract it from r's, and I can't subtract it from r squared. So I'm gonna make its little place right over here. It's got its own little column, and I'll show you how that works. We know that if I have 99 minus 99, now I have 0 over here, just how I need it. And over here, I have to write each piece separately because they're not common terms. So I have r squared plus 2r minus 99. Now I have a quadratic and it's equal to 0. So believe it or not, now I can start. Okay? And what this side looks like is that I can factor into 2 parentheses. The front times the front gives me the front. R times R. Wait till later. This is 1 times 99. 2 doesn't go. 3 times 33. 4, 5, 6 doesn't go. 7, 8, 9 does. 9 times 11. Since the fronts are the same, I should be able to pick out something that adds or subtracts to give me 2. 9 and 11, if I subtract those, I can get 2. So I'm going to use 9 and 11. This is good practice on your factoring. This is 11R. This is 9R. I need a positive 2R. So the way I'm going to get that, I have to subtract these. So if I'm going to subtract them, I need my largest one to be positive. So the 11 is going to be positive. The 9 is going to be negative. So what I'm going to do is take this, my actual answer, and just move it up here. Now I'm at the point where I have my factored information. It is equal to 0 because we made that happen. So now all we have to do is set each piece equal to 0. And our answers are negative 11 and 9. So I'm thinking this part from here to all of that isn't necessarily the problem, but maybe you'd like to see one more thing like this, that it isn't equal to 0. Is that right, Shaniqua?
I'm still trying to figure out when I missed this, but
The
I'm just-
factoring?
Yeah,
It was those days that you were looking at the wrong invite.
yeah. I'll probably have to
So-
go back on YouTube and watch it.
You know where to go to the YouTubes, right?
Yes, ma'am, I do.
Okay. Okay, well, make sure you do because there's a lot of information in there and it'll be a lot clearer. Okay.
Yes, ma'am.
I'm going to do one more. Let's do number 7. And then if you guys see something that you need help on, tell me. Other than that, I will release you to practice or watch YouTube videos. All right, number 7. The reason we're doing this is because number 7 is not equal to 0. So we have to figure out what to do about that. Okay, Our very first thing that we have to realize, we have a quadratic. Well, you'll see we have a quadratic. It has to be equal to 0, and it is not equal to 0. So we have to fix it. And the way we're going to fix that is take care of our parentheses.
K squared and 4 minus 4K.
Good job. Still not equal to 0. What do I need to do now?
Add the 3 to both sides.
Add 3 because I want this side to be 0, and that will make that happen. But if I add 3 to this side, good job, Josh.
It gets its own little place.
So we have K squared.
Minus
Yes,
4K
it has to have
plus
its own place. Now, we're actually at a starting place now because our quadratic equals 0. And here's our factoring. So if they say factor this quadratic, then you're done. But it doesn't, it says solve it. So what we're going to do is take this piece and make it equal to 0, and this piece and make it equal to 0. So I have K minus 1 equals 0, and K minus 3 equals 0. So K equals 1.
K equals 3.
Good. I was telling the students the other day, Josh, that a couple of days ago, is the first time I listened to one of my videos. And when I did, when I was listening, I heard you guys talking on the remote when I didn't even hear you. So my apologies to those of you that are talking to me and I'm not hearing it, because I heard you loud and clear giving me correct answers. And I'm sorry, I just didn't hear it. So if I don't hear you or acknowledge you, then holler at me. Just don't be mean, okay? Don't be mean to me.
It's all good.
I'm sorry.
I said it's all good.
Oh, I hope so. And Doris, I got your chat. I'll take care of that. So, any questions here? Or do you feel like you've got to handle enough, except for those of you that's missed the factoring part, you've got to go back to the YouTube. Okay, but those of you that are up with us on the lessons, do you feel confident enough to give it a shot?
Oh, yeah.
Yes.
Okay, Josh, Doris,
oh, yeah.
I heard
Pretty
that.
easy.
Mhm.
How you doing, Luannie? I haven't heard anything from you.
I'm doing good.
Good. It's really good to see you. I miss you so bad.
Yeah.
You'll have to talk to me more. I hope everything's going well for you. Okay, anybody?
I've got a good grasp on it so far.
Okay.